All right, class, we want to continue lesson 4-7 with our introduction of the law of sines and the law of cosines. This video is going to walk through the law of cosines. We're still dealing with non-right triangles, but in this scenario, we're going to know different elements of the triangle. If you look straight to the example, you'll see in this case, I know all three sides of the triangle, and I'm trying to calculate this internal angle. The law of sines won't help me there. I need at least one angle and two sides to be able to solve for another angle using the law of sines. But the law of cosines helps me greatly here. Now it looks a little crazy, but it's actually not that bad. It's kind of a play on Pythagorean's theorem. So we have the law of sines is a squared equals b squared plus c squared minus 2bc cosine of a. Now these letters can flip around, but the main thing you need to know is that if cosine a, cosine here, that means what has to be on the outside of the equal sign is the side length that corresponds to this angle. So if this were cosine of b, then this would need to be b squared equals a squared plus c squared. If this were the cosine of c, then this would be c squared equals a squared plus b squared. These two letters, b and c, must correspond to these two side lengths. In other words, I could not put equals b squared plus c squared equal or minus 2ac cosine of a. That's not the law of cosines. That does not work. So you just have to get familiar with the arrangement of the side lengths and where they go. And I think the biggest help is these two letters, these two variables, match up with what's on the right side of the equal sign. And whatever you're taking the cosine of, whatever angle, its respective side length has to be squared on the outside. So in this particular case, I think this is a hockey example in your book. What is the shot angle? We've got a hockey player out here, and here's the goalkeeper. It's a 6-foot goal. And from his angle, he's 20 feet from the left side post and 24 feet from the right side post. And we know all three side lengths. That is the law of sines. So you'll notice that I put A here, and I can move these letters around if I need to, but that's just convenient. So what do I know? I know side length A, that's 6, so that's 6 squared. Next side length is 20, going to square that. Add 24 squared to that. It doesn't matter if this is 24 and this is 20. Think about the math. They're both going to be squared. They're both going to be added. Just like it doesn't matter what order here. What matters is I'm taking the cosine of A. This is angle A. Then this 6 had better be on the outside and squared. That's what matters. Here, B and C, these two numbers correspond to the other two legs of the triangle that are being squared. And this, it just becomes algebra at this point. Just execute the math and just slowly kind of whittle it down until you're left with negative 940 equals negative 960 cosine A. Divide both sides by negative 960 and then take the inverse cosine of both sides. And you're going to get a shot angle of approximately 11.7 degrees. So I'm not going to work through the algebra on these last few steps. I'm hoping that you're comfortable with that by now. If not, ask me some questions. All right, let's go ahead, and I would encourage you to pause the video and work on the guided practice 5. Here we have basically a campsite with 2 checkpoints, and they've given you the distances between the campsite and the various checkpoints, and they're wanting to know what angle is created between the checkpoints and the campsite. So again, I labeled this one A because that's the angle that I'm solving for, okay? And so little a would be 1.5, and you can see how I've matched that up. I'm just filling it in. So I'll let you work through this from here, and if you don't get the correct answer, check your work, send me some questions. All right, let's look at one more example, the law of cosines. This is side angle side. So the previous example was side, side, side. But what happens if I have two side lengths and an angle? Well, this is a 3-step process here. Now you'll notice that this is angle C. So I've taken the cosine of C and I'm setting it equal to little c, the side length C. Alrighty, and in that case, I know my other two side lengths, so there's 5 and 8, both are going to be squared. 5 and 8 both go here, that's an 8, believe it or not, times the cosine of 65. And so just work through your algebra here. When you get c squared equals 55.19, take the square root of both sides, and now all of a sudden the side length is 7.4 degrees. Now that's all I need the law of cosines for. Now I can use the law of sines. I have an angle and its respective side length. I can solve for my other angle now, my other two angles, one using the law of sines and the other just using triangle properties. So the sine of A over 5 is going to be equal to the sine of 65 over 7.4. We just saw for C equals 7.4. That's going to give me an angle A of 37.7 degrees. Going to step 3, you'll notice that I changed that 37.7 to 38, just round to the nearest degree. And that gives me an angle B of 77 degrees. So you'll see I couldn't use the law of sines here initially. The law of cosines was step number 1. Then I transitioned to the law of sines, and then I just used my simple triangular principles or properties to solve for that missing angle. All right, go ahead and pause the video and work through example 6 and see what happens. All right, hopefully you had a chance to work through example 6. We're given triangle HJK with 3 different properties. We're dealing with side-side angle. And I went ahead and solved for number 1. Don't pay attention to this just yet, where it says the drawing is wrong. All right, I'm going to look at this and I say, okay, I'm going to solve for cosine of A. H is A. All right, you can rewrite this as ABC if you like. That's fine. But I plug everything into the law of cosines, and I get a side length for H here as 5.7. Then I went to my law of sines. Everything looks great. I get an angle of approximately 79 degrees. And I go to angle 3, and I solve for my remaining angle, which is 67. And you'll see that I say, no, that doesn't work. Now, let's stop and figure out why. All right, now look, this can get a little complicated, but I'm hoping in the next 2 minutes I can explain to you why this didn't work. And really, when we look at this, 78.8 degrees, let's just say 79 degrees, think about its supplementary. What's its supplement? Well, 180 minus 78.8 is 101.2 degrees. So which is it? Is it 79 degrees or 101 degrees? Well, the trick is the calculator doesn't quite know what's going on. So we ask ourselves this question, why does the law of sines in step number 2 not work? And it's because the graph, when we think about what we know of the sine wave, so I've sketched out a tiny little sine wave here, the calculator doesn't really know what's going on because it actually gives you a solution in 2 different spots. Now this would be through one period of a y equals sine x, right? And so what happens if we go to y equals 0.98104? Now, where in the world did I get that? Well, I took this, 10 sine of 34 over 5.7, and you can see I've rewritten. Just execute the math on that. Well, what does that give you? 0.98104. And so that's, if y equals this, y equals 10 sine 34 over 5.7, then it equals approximately this. So here on this orange line, that is approximately 0.98, right? And as I draw that horizontal line across on one period of the sine wave, I intersect it in 2 different places. And the calculator says, huh? What do you want me to do here? Okay, so that's the problem. Now, what do we do with it? All right, maybe this will help. Let's drop down to my work right here. And you'll notice that I got 78.8 degrees and 101.2 degrees. Well, why don't we convert that to radians? And so you multiply by pi over 180. And then I'm able to just honestly just approximate. Just approximate and say, okay, that's 80 over 180. That's 100 over 180. I'm just looking to get close on a graph. That's all I'm looking to do. And so this is going to be reduced to 4 pi over 9 and 5 pi over 9. That's going to be 79 and 101. I'm going to skip the next slide. Now look what happens. This is y equals sine x, and I have zoomed in. There's pi over 2 and 1, and we know the sine of pi over 2. The sine at pi over 2 is 1. And look at this point right there. That's your 0.98. This is that 0.98 line going across. And look, it intersects in two different places. Where does it intersect? Right about 5 pi over 9 and right about 4 pi over 9. Isn't that where we ended up? And so I was just trying to show you that this is what's happening. It's giving you these two spots, or well, these two spots exist. And in the calculator, it gave me the first one. I believe, if my understanding is correct, the calculators are basically defaulted to give you the first one. But what we're actually looking for is the one over here. Now, why? Whoop, back up. We'll do that video later. All right, and so look at what happens. This drawing is actually to scale, and we can see it play out here. 34 degrees, that's a true 34-degree angle. I measured 10 centimeters. I measured up about 45 degrees, 5.7. All of this measures. And look at the angle that is actually calculated. It is 101.2 degrees, roughly thereabouts. I can't measure 0.2 degrees on a protractor, but I'm telling you it's close. It's right at 101. So here's the 78.8 out here. That's the inverse. That's the other side. It's the supplement of it. And so what's actually being given is this internal angle. All right. I don't know if that makes sense. You can see it play out this way. What if we take the sine of 34 over 5.7 and set that equal to the sine of j over 7? Well, that ends up giving us right about 43 degrees, and you can see mine here. This is a rounding error. These calculations are the same. This is just simply a rounding error. And so just stop and think about that for just a moment. All right, guys, I know that is an extremely challenging example, and you're probably walking away with questions like, well, how do I know? We will talk more about that in class.